This is Ms. Black, and this is Open Campus, and we are now in Module 12. We are in Part B of this module, and if you recall from the previous module, we were learning about exponential equations and logarithmic equations and how they're related. And we learned that we could take either one of them and transform them, change them to be each other. We're going to use that fact today to solve some more exponential and logarithmic equations. But before we can actually solve those equations, we have to learn some new rules or properties. Now, I want you to think back to elementary school. Suppose in elementary school I gave you 2 parentheses 3 plus 4, and I asked you to work it out. Well, we would follow order of operations. We would do what's inside the parentheses first, so 3 plus 4 is 7, and then we multiply that by 2 and get the 14. When you guys got to Algebra 1 and I asked you almost the same thing, I asked you 2 parentheses x plus 4, could you do what's inside the parentheses? No, you can't add an x to a 4. So what you had to learn how to do was distribute the 2. And remember, that was a new rule or property. And at first it didn't make any sense. You're like, why am I doing this? Well, we taught you to distribute would get rid of parentheses. So if you had 2 parentheses x plus 4 and you distributed, you got 2 times x, which is 2x, and 2 times 4, which was 8. Correct? Well, today we're going to do the same kind of thing. We want to solve some exponential and logarithm equations today, but to solve them, we got to learn some new rules or properties. So just keep that in the back of your mind as we're learning these new rules, that the purpose is to solve an equation. Just like in elementary algebra, the purpose of distributing was helping you solve an equation. Okay, let's go to our class notes. Okay, so if you look at your notes, I just talked about how we're going to relate this to algebra. We're going to learn a new property to help us solve an equation. The first property is called the power rule. And the word power means exponent. So to do this rule, you're going to have an exponent. The rules we talk about today are rules with logarithmics, which means you've got to see the word log in there. So if you look down here, the power rule says in symbols, log base b m to the p. So we see the word log because the properties have to do with logs today. And then we see m, and m has an exponent on it, or a power. That's the p. And the rule today says that if you have a power, you could take that exponent, that power, and bring it down in front of the word log. And that's why it says it equals p log base bm. Now, do not memorize that. That is not a formula you have to memorize. What you've got to understand is what it's telling you. It's saying anytime you have a log and there's a power behind it, an exponent, you're going to take that exponent and bring it down in front. All right, let's go up to the board. Okay, guys and gals. So again, here's this new rule, this new property. It's the power rule. It says if you have a log expression, and behind the log, there's a term with an exponent, a power, you're going to be allowed to take that power and bring it down in the front. And now if it's in the front, it's no longer an exponent. It's just connected by multiplication. That's a pretty cool rule if you think about it, that you could take an exponent and bring it down and it's no longer an exponent. The problem with that rule is you can only do it with the word log, whether it's log, common log, or ln, natural log. So what I don't want you all doing is this. If I write on the board 2 cubed, don't you dare tell me, oh, I'm going to bring the exponent down, and that's going to mean 3 times 2. Because does that make sense? What is 2 cubed? That's 2 times 2 times 2, which is 8. If you rewrite that as 3 times 2, does that make 8? No, that makes 6. So I don't want you thinking if you see an exponent, always bring it down. This rule says you can bring an exponent down when you see the word log. So let me give you a real life analogy how you can remember this. Have you ever been at home and there's some trees in the neighborhood? and you hear in the top of the tree, meow, meow, meow. We've all had the famous, the cat stuck in the tree. I want you to think of this base right here as the tree and the exponent as the cat. So you got a cat stuck in a tree, but you're too short to climb up the tree and get the cat down. So most normal people, when there's a cat stuck in a tree, who do you call? You call the fire department. Now, when the fire department comes to get the cat out of the tree, they're going to take off the truck, the ladder, and they're going to use a ladder to climb up the tree to get the cat. Well, that's what I want you to relate this to. When you see an exponent, you can bring it down if you have a ladder. And our ladder is the word log. So think of L as a ladder. The only way to get an exponent down is if you have the word log. That's your ladder. And then the cat can come out of the tree and be safe on the ground. So you can only bring down an exponent when you have a log. So the first three examples in our class notes say to simplify these. Now these are not equations, they're expressions. I do not see any equal signs. So we want to simplify. If you look, expression 1, there's the word log, and there's the tree, there's the base behind it, and there's your exponent. So according to the power rule, we could take this exponent, we got our ladder, and bring it down in front. And we can rewrite this as 4 log base 2, 8. That's what the power rule says. If you have your log, the exponent comes down and it's no longer an exponent. If I have log x to the 5th, do you see your exponent? Yep, it's a 5. Do you have your ladder, your log? Yes, you do. So now the log, you can bring it down in front of the exponent, and this will be written as 5 times log x. The exponent comes in front, so now it's gone. See how simple that is? It's a property, a rule. We're going to use it in a couple of minutes to solve equations. Now this next one's tricky. It's natural log square root x. But I don't see an exponent. Do you? No. Square root is not an exponent. But we've already learned in previous modules, over and over, we talked about this. A square root symbol can be replaced with what exponent? No, not square. Think. Square root can be replaced with what exponent? That's right, the exponent 1/2. So we can rewrite this as natural log x to the 1/2. This exponent, when an exponent's a fraction, it means a root was there. Now that we write it as an exponent, now we have a log, our ladder, we can bring it down in front, and this really means 1/2 natural log x. And we can leave the natural log x in the middle of the fraction bar. Or, if we want to write this as one big fraction, anything in the middle of the fraction bar floats to the top, so that would be natural log x over 2. So that's what the power rule says. Now, let's talk a minute. When I last left y'all, we talked about how we have buttons for natural log and common log on our calculator. So let's talk about, can we type these in our calculator? So let's start with C. I have natural log x. I have a button for that on the calculator. Remember, it's the ln button. But we can't type this in because you can't type in a variable. So even though we have this button on a calculator, we can't type in the letter x and get out a number. So we would leave this alone. This is in simplest terms. If we go to this expression, this is log, and it doesn't have an invisible subscript. So we talked about that in the last modules. When you have log, that's called a common log, and the invisible subscript is base 10. We have a button for that on the calculator. Remember, that's the log button. But again, we can't use it because behind the word log, there's not a number. There's a variable. So this is simplified as far as it can go. This last expression up here has log, but be careful. What base is it? It's base 2. We can't use our calculator for that. Again, we talked about it. The log button on your calculator is on invisible base. It's base 10. How are you going to remember that? If you look above the log, it says the number 10. So you can only use the log button if it's a base 10. Well, this is base 2. So you're going to say, well, I have to leave it alone. The last module we discussed this. You can work a log in your head. This 4 stays. It's connected by multiplication. This is base 2. So remember, when you talk about a log, I'm asking you, what exponent do you put on the base to make the number? What's the base here? 2. What exponent do you put on 2 that would make an 8? Would it be 2 to the first? That's 2. Would it be 2 squared? That's 4. Would it be 2 cubed? Yes, it would. 2 cubed is 8. So the value of log base 2, 8, is the number 3, because that's what it's asking you. Anytime you get an answer for a log, you're telling me the exponent that you would put on the base. And you would put a 3 on that base to make 8. So that's why that becomes a 3. And 4 times 3 would make that expression become a 12. So you always have to check with logs if they're simplified all the way. If there's variables behind logs, then you're done. But if there's a number behind a log, then you got to ask yourself, can I use my calculator or can I work it out in my head? Okay, in our notes, if you look at the next page, you have a multiple choice here. It says, which of these expressions are equivalent to log 10 to the 5th? First thing, can you use your calculator? Sure you can. This is log. We don't see the base. So it's understood to be what number? That's right, it's understood to be 10. So because we have a button on our calculator, we could type that in. So remember, we talked about using a correct calculator. Okay? A good scientific calculator is the Texas Instrument TI 30X2S. That calculator will type just like my graphing calculator. Here's a fancy graphing calculator for $125. Don't go buy one of these for college algebra. You just need a basic one. But the important part is what you read is what you type. So to type this in, we're going to hit LOG. Then it's going to open a parentheses. And then we're going to type the number 10. And how do we put an exponent? That's our caret. Remember our up arrow? So we're going to hit our caret, type 5, close the parentheses, and hit equals. And this spits out 5. So obviously out of the 4 choices, this is one of the answers. But is this the only answer? Heck no. Which one of these other expressions equals 5? Well, again, can you use your calculator? Sure. These all have invisible bases, so they're base 10. They're common logs. So we could type them in our calculator. So let's type log of 100,000. So we hit LOG, and then we just type 100,000, close your parentheses, hit equals. What does it spit out? Oh, it spits out 5. So this means the same thing. So this also is equal. Let's do the next one. This says log 10. So we're going to type log, hit the number 10, close parentheses, hit equals. Does this spit out 5? Nope, this one spit out 1. That's not the same answer. So if everybody looks, let me explain why this spit out a 5 and this one didn't. Again, what's the invisible base? 10. I'm asking you, what exponent do you put on 10 to make 100,000? How many times would you multiply 10 to make 100,000? 5 times. That's why it spit out a 5. On this expression, again, the invisible base is 10. How many times would you multiply 10 to make 10? That's only 1 time. 10 to the first would be 10. So that's why the calculator spit out a 1. All right, let's look at the last one. This is 5 log 10. Well, you just told me log 10 is going to give us a 1, and 5 times 1 is 5. So this also is equivalent. And if you look, what they did is the power rule. They took the 5 and said, oh, I have an exponent. There's my ladder. Let me bring it down in front. So the 5 would come in the front and would leave log 10. So that's why all 3 of these expressions are equivalent. So far, so good? All right, let's go back to the notes and see what we're going to do with this property now. All right, so if we go back to the notes, we just covered examples 1 and 2. Now, here's the purpose. Everybody look up there. I have an equation. 5 to the x equals 134. And who am I solving for? I'm solving for x. So we got to learn how to solve that equation. And when we solve that equation today, we're going to use this new property. All right, so it's whiteboard time. It's more work. All right. If you remember in the last module, we said that this was an exponential equation. Why is it exponential? Because exponential means the word exponent, and there's an exponent that's a variable. So when your variable's in the exponent spot, it's exponential. We said in the last modules, in 11, these were really easy to solve if you could get the bases to be the same. What's the base on the left? 5. Can we do anything with 5? Nope, it's prime. We're stuck with 5. What's the base on the right? 134. Can we do anything with 134? Well, yeah, it's an even number. We can come over here and divide it by 2. So we know 2 times 67 is 134. Can we factor 67? No, that's prime. So we have a problem now, guys, because we learned in Module 11 that to solve an exponential equation, you got to get the bases to be the same. There is no way to make 134 be the number 5. So that's why we have another method. So when we're solving an exponential equation, if you can't get the bases to be the same, then all we're going to have to do is get the cat out of the tree. And that's important. To bring the exponent down, we're going to need a what? A ladder. Our ladder is the word log. Now we have 2 choices. Do we use log, common log, or ln, natural log? Well, there's a very easy way to decide. Everybody look at your calculator at the natural log button, the ln button. What's above it? The letter E. So you will use ln if you have in your equation a letter E. Do we have that crazy irrational number E in our equation? No. So that means we'll use common log base 10. You always use log common log when you're dealing with just numbers. You use natural log when you're dealing with E, that crazy irrational number. So step 1 is to get the cat out of the tree, we need our ladder. We're going to bring in our log. Well, sweeties, if you put a log on the left to keep balance, you got to put a log on the right. Basic property of equations. What that lets you do is it lets you use the power rule to bring that exponent down. So now we have x natural log 5 equals natural log 134. That's the purpose of the power rule, to get the exponent, the cat, out of the tree. Now, guys, this is real simple. Who are we solving for? We're solving for x. Natural log of 5 is connected to x by multiplication. How do you move multiplication? You do division. So we divide by natural log 5, natural log 5. Something divided by itself cancels. This is a whole expression. The log never comes apart from what it's behind. You're not dividing the word log and then dividing the number 5. You're dividing this whole expression with this whole expression. So they're canceling. That leaves x. Now, it's very important you understand this. You're going to be asked normally for 2 different types of answers. We're going to want the exact answer and then around it, an approximate answer. The exact answer is when you leave the log words in the answer. So if I said, what is the answer to this equation? The exact answer is what you have here. It's the word log 134 divided by the word log 5. You cannot get rid of the word log. You can't separate it from its number. So this does not look exactly like this. So it doesn't divide. It doesn't cancel out. That's your exact answer. Now you'll be asked for an approximate answer. And that's when you go use your calculator. So let me grab my calculator. And we're going to type in exactly how we read this. And when you read a fraction, you start with the numerator, so we're going to type log 134. But then you got to remember to close the parentheses, because if the log opens it, you got to close it to show that's the number with log. So I'm going to close my parentheses. Division bar means divided. Hit the division symbol. And then we're going to type log 5. It opens a parentheses. You're going to close it. And then you'll hit equals and get a crazy decimal. Let me hold that up to the screen. I know that's going to be hard to see. Can y'all see it? Okay, you get that crazy irrational number. Now we're going to round. Read your directions. Sometimes they want the nearest tenth, the nearest hundredth, the nearest thousandth. I'm going to write this decimal out for y'all to see it. I got 3.043198972. If they ask you to round it 4 decimal places, which digit is in the 4th place? It's the 1. Would it stay a 1 or go up a 2? Well, we know to round. Underline the digit, look next door. If that's 5 or higher, up it 1 more. So that's a 9, which means this is going to go up to 2. So this approximate answer is x is approximately, and that's why we use the squiggles. You can't use the equals. It's not exact. 3n 432 10,000s. So what we learned is if you have an exponential equation and you can't get the bases to be the same, the only other choice you have is to get the exponent out of the tree by bringing in your ladder, your log. All right, let's look at our notes. I think we got another one to solve. Okay, our second equation, let me put down my calculator, is 7x plus 2 equals 410. So again, that's an exponential equation. Your variable's in the exponent spot. First thing you check, can you get the bases to be the same? Nope, that's 7. It's prime. It's in lowest terms. That's 410. Even if you came over here and decided to factor 410, you would get 41 times 10. 41's prime. So there's no way to make these numbers become a 7. Fair? Good. So now the problem is the exponent's stuck up in the sky. To get the cat out of the tree, you need to bring your ladder. What ladder are we using? Log common log or ln natural log? Very good. You don't see an e, so we use our common log. So we put a log on the left. That means we put a log on the right. What that log lets us do is take this exponent and bring it down in front. How is that exponent connected? Multiplication. So to show multiplication, because there's 2 terms here, I'm going to put it in parentheses. So this is going to be x plus 2 natural log, common log 7 equals common log 410. Now that you got the exponent down, now your job is just to get x by itself. Well, this is connected by multiplication, so we need to divide by common log 7 to get it out of there. So let's divide by log 7. Do not go use your calculators right now. You wait till the very end to use your calculator. If you use your calculator right now, you're going to get all these ugly looking irrational numbers, these crazy decimals, and you're going to get confused. You wait till you get x by itself. Once you got x all by itself, then you go use your calculator. So because common log 7 divided by common log 7 is exactly like, they cancel out. That leaves us with an x plus 2. Do we need the parentheses anymore if that's on the left side by itself? Nope. So let's drop them. On the right side, we're going to leave what we have. Log 410 divided by log 7. Again, you just can't cancel out the word log. That word is connected to something behind it. These are not the same at all. Leave them. Now, are we done solving? Heck no. I don't see x by itself. So to move and add 2, we're going to subtract 2. Here's the big question. Are you subtracting 2 from the numerator Are you subtracting 2 from the denominator, or are you subtracting it from the whole fraction? Very good. You're subtracting 2 from the whole thing, so that's why it goes in the back. So the exact answer is x equals common log 410 divided by common log 7 minus 2. Once you get x isolated and have the exact answer, now you can go use your calculator. So let me go get my calculator. All right, we type as we read it. So we're reading the numerator first. So we type log 410. It opens a parentheses, we close it. Then we hit division bar. So we're going to hit the division symbol. Then we're going to type log 7. It open a parentheses, we're going to close it. Those parentheses tell the calculator what number belongs to each log. Then we're going to say subtract 2. And remember, the subtract is the big subtraction symbol. So we hit subtract 2, hit equals. We're going to get out an irrational number, a crazy decimal. I'm going to write it down. So I get 1n, 0916939192. Let me show you what it looks like on my screen there. So again, if you see it, there it is. Okay? We're going to round. Let's round this time to the nearest tenth. What digit's in the tenths? That would be the 0. Is it going to stay a 0 or go up? Well, we underline the digit. We look next door. That's 5 or higher. It goes up 1 more. So that 0 becomes a 1. So this would be approximately 1 and 1/10. And depending on what book or what the question asks, it depends on what you're rounding to. So you're going to have to read. Okay, you got it so far? Pretty easy, right? Using the power rule to get the exponent down. All right, let's try our third equation. Let me put down my calculator. All right, my third equation I want to solve today is e to the 1 minus 5x equals 793. Okay? Again, it's an exponential equation. The variable's in the exponent spot. Now I want you all to pay close attention. We're not solving for e. E is related to pi. You all know when you see the pi symbol on the screen, your brain automatically pops up, 3.14. This symbol stands for a number. We've already discussed, this e stands for a number. It's 2.7 blah, blah, blah. So we're not solving for e. Our variable is x. That's who we're trying to get by itself. Uh-oh, where is x located? It's up in the exponent spot. So our first thought is, can we get the bases to be the same? Well, that's an e. And that's a number, 793. And there is no way to change that number into a letter or change that letter into that number. So there's no way we can get the bases to be the same. So we're going to have to bring in our ladder. But because we're dealing with e now, which log do we use? Do we use common log, log, or natural log, ln? Very good. We use ln, and there's no way for you to screw it up. If you look at your calculator, above the natural log button is the letter e. They go together. So what we're going to do here is we're going to write, okay, I got a natural log. I'm going to put it on the left side. And that means I got to put it on the right side to keep balance. So I put my ladder on both sides. That ladder allows me to take this whole exponent and bring it down. That's the power rule. But again, because there are two parts to this exponent, I'm going to put it in parentheses so I know it's connected by multiplication. Okay? Now, we're going to have to move natural log of e away from this. Well, it's connected by multiplication, so we should do division. But wait a minute. We learned about that in the last module. Take your calculators and type in natural log of e. And let's see what the calculator gives us. Do you remember how to do that? Okay. So if you remember how to do that, you type what you read. So if I want you to type in, oh, marker don't work. if I want you to type in natural log e, you would hit the ln button, then e is above it, so then you would hit second ln, okay, and what happens is it opens a parentheses, it puts e on the screen with a caret, and we discussed this. Every time you hit second ln and get the e to come on the screen, it's waiting for e's exponent. What's the invisible exponent on e? It's 1. So now we're going to type a 1. My calculator opened 2 parentheses, so I must close 2 parentheses. Every calculator works a little bit differently, so yours may not work exactly the way I'm showing you mine works, but if you buy a brand new calculator, they all should pretty much work the same. Hit equals. What do you get out, guys? I got out 1. Let me show you. So if you look very carefully, there it is. Oh, let me type it in. Let me move it back. There it is. Okay? Now, why is that important? Because really, in all honesty, we shouldn't waste time having to type this in. One of your memorized facts for this chapter is to understand every time you see natural log e side by side, you can cross it out and put a 1. And is 1 times 1 minus 5x going to change that? Nope. It's going to be 1 minus 5x. Now, all we got to do is get x by itself. So we're going to move the 1. That's an add 1. So we're going to subtract it. Here comes the next boo-boo. Are we subtracting the 1 from 793? Or are we subtracting the 1 from the natural log of 793? Okay, guys. This number, 793, is connected to this word. They don't come apart. So you're subtracting the 1 from the whole thing, which you cannot do. So what you got to do when you write this is put the 793 in the parentheses, just like the calculator would, and minus 1. So you know this expression stays together, and then from it we're going to minus 1. Now we're not done. X is not by itself. We still got to divide by negative 5. We still got to divide by negative 5. Cross out the negatives. We get x equals. Well, now we got a problem because we've discussed this over and over again. When you type a final answer and it's a fraction, it has a fraction bar. The denominator always has to be positive. So if you've heard since algebra, when you see a negative in the denominator, you float it up. But who does it go to? Does it go to the natural log? Does it go to the negative 1? Or does it go to both? Very good. It goes to both. This division bar means you're dividing this term and this term by negative 5. So when you float that negative up, it's going to both. So what's happening is this negative is going away. You're floating it up here, that becomes negative. But when you float it up in front of the negative 1, 2 negatives would make a positive. And isn't that what you've always learned? When you divide by a negative, it changes the symbols. So this exact answer is little negative natural log 793 plus 1 over 5. That's how it should be written on your paper. Again, the 793 is in parentheses to make sure you understand that number belongs to the natural log and it can't be separated. And it can't be done anything to it. Now, typing this in is a nightmare because you have to be smarter than the calculator. The calculator is not smart at all. The calculator is going to give you an answer for what you type in. It is very important you understand this division bar goes all the way across, which means who are you dividing by 5? Are you dividing the natural log by 5, the 1 by 5, or both of them? I hope you say both. And it's important to understand this. The only way the calculator is going to know that both of these are getting divided by 5 is if you type parentheses around the numerator. I can't tell you that. The calculator can't tell you that. You've got to know that. You've got to tell the calculator, work all this first in the numerator, get it to be a number, and then take that number and divide it by 5. So when we type this in the calculator, we're going to type little negative ln, it opens a parentheses. We're going to type 793. We're going to close it. That tells the calculator only this number belongs to the natural log. We're going to add 1. We're going to close it again. So you opened a parentheses in the beginning, There's your open parentheses. You close the parentheses. That now tells the calculator what's going on here is to do all this first. Make that one number. Make sense? Now that you get all that typed in, you would then hit divide by, hit the division bar, and 5. And that tells the calculator you want everything in the numerator divided by 5. And you would hit equals. Okay, let me bring it up and see if you can see it. Okay, if you'll look at that closely, move back, and y'all can see it. All right, so what I got out was x is approximately negative 1.135164644. And depending on what they want you to round it to, you round. Let's suppose we're going to round this to the nearest tenth again. That digit 1 is in the tenths. Is it going to round up or stay the same? Underline the digit, look next door. If that's 5 or higher, it would go up one more. If it's 4 or lower, you ignore. That's a 3. It's lower. That stays the same. You ignore. So this would round to approximately negative 1 and 1/10. Y'all with me? All right, I got one more exponential equation that we're going to solve today. All right, so let's erase. All right, let's put down the calculator. Okay, our last equation. 3e to the 5x equals 1977. Why is it an exponential equation? Because the x is in the exponent spot. Can you get the bases to be the same? Well, let's look. The base is the term that owns the exponent. Whoever the exponent's connected to is called the base. Here's your exponent, 5x. Who owns that? Who does it belong to? It belongs to just the letter e. That's your base. Can you get base e and 1977 to look the same? No, you cannot. So I know what you're thinking. You're saying, okay, call the fireman, bring in the ladder. Well, we got a problem, guys. You can't just go and throw the ladder anywhere. We even put the ladder at the beginning of each equation. And we know if we're dealing with e, our log we would use would be ln. Now everybody look closely. We got a problem. Here's the cat. Here's the tree. Here's the ladder. We got something in between. That's like me. I'm the one that called the fire department. Are they going to put the ladder up and let me stand there in the middle between the ladder and the tree? No. They're going to tell me to move over. So one of the most important things we've been learning in all these modules on solving equations is before you can get rid of the thing you don't like, you got to isolate it. Well, that's the same thing here. You can't bring in the word log until you make sure the exponent and the base are all by itself. We have to move something. We have to move that 3. How is that 3 connected? Multiplication. So we're going to do division. Now we'll get e to the 5x. And let's hope that divides nicely. 3 goes into 19 6 times. That'd be 18 with 1 left over. 3 goes into 17 5 times. That's 15 with 2 left over. 3 goes into 27 9 times. So I divided in my head. Now that we got e, the base, by itself, now you can bring in your ladder. Now you can write, all right, I need a natural log to get my exponent down. I need a natural log to get my exponent down. Why do we put it on both sides? To keep balance. So now we're going to take our exponent. We're going to use the power rule. We're going to bring it down in front. We're going to write 5x, natural log e. I don't need parentheses because that's one term of monomial. I know that's connected by multiplication. Do we have to do anything with natural log of e? No, because you're going to memorize a fact. Natural log e, side by side, always make the number 1. And 5x times 1 is 5x. Now we're going to solve. We're going to divide by 5. And there's our exact answer. Our exact answer is natural log 659 divided by 5. So now we'll get out that handy-dandy calculator. Okay? And we type what we said. We're going to always type the numerator first. So we hit ln. We type the number that goes with natural log, 659. We close the parentheses. telling the calculator 659 is with natural log, and then we hit divide by 5. We get a lovely irrational number, a decimal. We get x is approximately 1.298144,707. And then we'll round according to what they say. If they said to round to the nearest hundredth, what digit is in the hundredth spot? It's a 9. Underline the digit, look next door. If it's 5 or higher, it goes up one more. Well, that's 5 or higher, so 9's going to go up to 10. But you can't put a 10 in this spot. So you put down the 0, you carry the 1. And that's why when you round this, this is approximately 1.30, 1 in 30 hundredths. Because if I round to the nearest hundredths, I got to show my hundredths position. So what we learned in this module is one new rule, power. If you have an exponent stuck up and you want to get it down, you need to bring in your ladder, common log log, natural log ln. Okay, I'll get you in the next module.